Okay. Hello, everyone. Good afternoon. Today we are looking at the introduction to blockchain, which will set the base for the future sessions so that we can deep dive into the technology. This is a trending technology these days. This has emerged 10 years back and now it is in adoption phase. Let's look into what is blockchain. The blockchain is a distributed database of records of all transactions or digital events that have been executed and shared among participating parties. Basically, blockchain is a distributed shared ledger which is maintained by all the participants of a blockchain network. What is the difference between a distributed database and a blockchain? Distributed database also replicates the data in multiple places, but it is controlled by single authority. Whereas in blockchain, it is decentralized. The power is decentralized across many participants. That's the advantage of blockchain. As you see in a blockchain, all the transactions are added to a block, and then each block is linked to the next block. The Genesis block, which we see, is the first block of any blockchain. Whenever we hear about Genesis block, it is the first block created on that blockchain. And the hash of that block is stored in the next block, linking the blocks together. Every block will have the previous block's hash. In this way, the data can be traced at any time. This is how the blockchain looks. Every dot that we see in this image is a node. A node is an electronic device which has the power to read, write, and execute a program. Is a node. So all the nodes are connected in the blockchain network. Each node is connected to some nodes, and this is how every node is connected to every other node. Blockchain, the advantages of blockchain is it is immutable. Once the transaction is added in a block onto a chain, it is immutable. It cannot be changed or erased. It is transparent. Why it is transparent? Because the same data is replicated across all the participants in the network. So everybody can see that a transaction happened on a date. So that is transparent. It is secure. Each transaction is cryptographically secured in the network. Every transaction is signed by the sender. So it is added to a block, and then the hash is calculated of the block and saved in the next block. In this way, it is secure. If anyone attempts to modify any transaction in block 2, then they have to modify the hash, then the hash will change, and that hash has to be changed in the next block, and so on. And this has to be repeated over all the nodes in the network. Then somebody can corrupt the system, which is why the blockchain is very secure. When the data is shared among multiple parties, unless all the parties are corrupted, no one can change it, or they should majority of the participants should be corrupted. We will look into it detail as we move forward. Here is the big picture. When we have trust, the value is known. And when the value is known, it is accepted by majority of the people. But can we do the reverse of this? Can the size create the trust? It, It was not possible before blockchain, now it is possible. Because creating the trust among a group of participants is not very easy, and blockchain solve that problem. We will see how. Like for example, RBI, we use fiat currency which is issued by RBI. Everybody knows the value of the note. If 10 is written, which means we have trust on RBI that they will deliver 10 rupees to the holder of the note. So the trust is there and the value is known, and then it is accepted by all the people. But when the value is unknown, when it is accepted by size, can we create the trust? This is exactly what happened with Bitcoin. Blockchain is a confluence of distributed computing, cryptography, and game theory. These are all pillars of the blockchain. Distributed computing, which shows the ability for the data to be present everywhere on the network. Cryptography, it executes complex problems and it provides the security. Game theory, the ability to make decisions with partial data. When many nodes are part of the network, each node should accept that a transaction is valid with the data that they have. So that comes from the game theory. There are different types of blockchains. One is public, private, permission. Public blockchain means anybody can download the blockchain software if they have the computation power and be part of the network. Whereas private is owned by a single organization, where the single organization will have the control over the blockchain network. Permission is the network in which multiple participants have the control. This has a limited decentralization. Public network is completely decentralized. Private is not decentralized. But private network is utilized by big organizations where they want to share the data among multiple branches or multiple departments and have the transparency. The first killer use case of blockchain is Bitcoin. We will see what is Bitcoin. Bitcoin is a peer-to-peer electronic cash transfer system, which means there is no intermediary, there is no bank in between. Anybody can transfer the bitcoins to anybody in the world. It's a cross-border electronic cash transfer system. The Bitcoin was launched in 2009 by Satoshi Nakamoto. Nobody knows who is Satoshi Nakamoto, whether it's a single person or a group of persons. Nobody knows till now. It was launched in 2009. That's where the first Genesis block is created on the Bitcoin network. Here, the blockchain name is also Bitcoin and the currency name is also Bitcoin. What is cryptocurrency? It is the native currency that lives in a blockchain. That is native to the blockchain. Bitcoin, it's not like a coin or it doesn't have any unique ID. Each coin doesn't have any unique ID. It's just a number and the owner of the funds. Let's see how a Bitcoin block looks. Since blockchain is a public network, Bitcoin is a public blockchain, anybody can see the transactions. Nothing is private here. Everybody can see the transactions and created and all the blocks in the blockchain. In blockchain, Each block, all the transactions, some transactions are grouped into a block and then committed to the blockchain. If you see here, these are the list of blocks. The latest block is 7,46,287. We can see all the way up to the Genesis block. If you search for the Genesis block, this is the first block, mined on January 9, 2009 by Satoshi Nakamoto. This block has only one transaction, that is coin-based transaction. A coin-based transaction means it creates new coins. What is mining? Adding the transactions to a block and committing it to the chain. This is the first block created by Satoshi Nakamoto on 2009. At first, it doesn't have any value, zero value. But after some time, in 2010, somebody from the Bitcoin forum announced that they want to exchange 10,000 Bitcoins for two pizzas. And that is the first transaction happened, and then the first value was decided for Bitcoin. And then the Bitcoin price went up depending upon this demand and supply.
So one question.
Yeah, sure.
Yeah. So how is this hash value, based on what the hash value is getting generated?
This hash value.
Yeah.
This hash value is generated with all the information on the header and the transactions.
Okay. So it combines everything and then
It's
an hash.
yes, right. That's why when we change any transaction, the hash value changes.
Yeah. So does it uses its own hashing algorithm, or it does
Bitcoin uses SHA-256.
SHA-256?
Yeah. Since this is a public blockchain, right? Everybody can see the transactions like this, and we can see who owns this address, owns this 50 Bitcoins here.
Yeah. So can you just go a little bit up?
Yeah.
There's a Merkle tree, right? Merkle tree.
Yeah. Right.
What is the use of this? It's just giving you where it started and where it is ending.
This is the proof of transactions included in this block. Merkle tree is made up of hashes of the transactions.
Okay.
Yeah, each transaction is hashed, and then the two transaction hashes, a hash is generated for the two hashes of the transactions, and the root is created, and so on, right? It builds like that as a tree.
Okay.
And the root is stored here.
Okay.
This is used to verify if a particular transaction is included in the block.
Yeah. So it means that true transactions are combined together to form the root
Yeah.
Merkle tree, right? So
Right.
the child transactions hash values are combined to form the root
Merkle tree. Yeah.
right? Yeah. Okay.
Yeah. This is the header of a block. A block has a hash. This is the hash of the current block, and it has confirmations. Confirmations means how many blocks are added after this block. Timestamp denotes when the block was created. This is the proof that a transaction occurred at that time, and nobody can deny because 9,000 nodes has this information. Once a transaction is committed to a blockchain, it is true forever. That's why it is immutable and transparent. And height is the block number, which is 1. Minor is unknown. Number of transactions included in this block only 1. And difficulty is 1. The difficulty decides the time it requires to generate this block. Also, the difficulty decides like how long it takes for a miner to create this block. Each When many participants are there in the network, particularly in the distributed systems, there has to be a consensus protocol using which everybody agrees on a block to be added to the chain. The consensus algorithm for Bitcoin is proof of work. What does proof of work is? After deciding which transactions should go into a block, and then all the information miner has, now miner has to identify one particular number which is nonce. That will adding that the hash of the block will be this, which is less than some target value that is decided by the protocol. That is what is difficulty. Difficulty is changes depending upon the time the block is taken to be created. In Bitcoin, each block is mined on an average of 10 minutes. 7 transactions per second is the TPS on Bitcoin blockchain. This includes mining the block and then broadcasting the block through the entire network. Every miner in the network competes to build a block to get the mining reward. In this first block, the mining reward was 50 bitcoins, which is huge at this current price. So, this block reward decreases into half after every 4 years. Right now, the current price we can check. This 3.25 bitcoins, I think. Point 0.15 bitcoins. In each block, the first transaction is the coin-based transaction.
There is a company called Coinbase. Is it different? This one is a different. Coinbase is a term used here.
Yeah, yes. Coinbase is the name for the transaction that creates new bitcoins.
Okay.
Coinbase is a company, it's an exchange where you can transact cryptocurrencies. Both are different.
Yeah, one question. Once you are talking about a difficulty, so what is a difficulty level will be created? Means it is 0 to 1 or it is maximum more than 1?
Oh, more than one. It depends upon the time that the miners are taking to create a block. If the block is getting created in 7 minutes, then the difficulty level will be increased. If the block is getting created in if it takes more than 10 minutes, like 11 minutes or 12, maybe 15 minutes, then the level will be decreased. The difficulty level is adjusted after every 2000 blocks.
So it means here 24 seconds, 1 minute, mined at 24 seconds, 1 minute, 35 minutes, 1 hour, right?
Yeah, correct.
So one question is again, what do they
Yeah.
mean by, so when they tell mining, right, in a blockchain,
Yeah.
what do they actually do? So they tell that there is a problem which we need to solve and is it something like that? Because I still puzzle what is called mining, because they tell that.
Mining is when all the transactions are broadcasted to the network. Miners receive the transactions and they maintain in a data structure called mempool. These are pending transactions. Miner takes these transactions and add to the block and work on creating the nonce. This whole process of adding the transactions to the block and solving the puzzle, that proof of work puzzle, is mining.
Okay. So who gives that problem, that puzzle?
The network, it is there in the protocol.
Oh, protocol randomly takes the puzzle from the internet.
Yeah, that difficulty level will be broadcasted to the network. Everybody will work using the same difficulty. Now this difficulty is very big, see,
Okay.
and the number of zeros before the hash is also more. And the block reward currently is 6.25 bitcoins. $2,874 transactions are included in this. We can see all the transactions that are included in the Bitcoin. And in Bitcoin, these transactions are stored as UTXO, which is unspent transaction outputs. Every transaction has an input and outputs. This, whatever we see here, is the address to which the funds are transferred. Okay, funds are taken from this address, which is to 7.24 bitcoins, and then these are transferred. 7.24 change is transferred to this, and the rest is transferred to this address. If we observe, this address and this address is same, which means this person is transferring 0.003 to someone, and the rest is transferred to the same person. This is why, because we can assume the Bitcoin transaction as a check. Check contains who wants what. Exactly the same way, this outputs, we call this as input of a transaction, this is output. Before this transaction is executed, Bitcoin has this information. Okay, this address owns this much. And now this person wants to transfer some funds to this address. They, in a check or a note, it has to be completely utilized. If I have 7.24 note, I cannot cut the note and give it to multiple persons, right? Give some and keep the other half with me. No. If I have to spend 5 rupees, I have 10 rupees note. I give away 10 rupees note, I get 5 rupees change back. The same way here in Bitcoin. The current address has 7.24822,358. From that, a part of it is transferred to someone, and the rest should go back to the original owner. If we don't create this particular output, which means minor things, the balance amount is the transaction fee. This is to be remembered very carefully, that every time, anytime we want to transfer funds, we transfer the change to the owner automatically. And some we can give as a transaction fee to the miner. The more transaction fee, it is more lucrative for the miners to pick up the transaction. If less transaction fee, there's a chance that they do not pick up faster, it will be delayed. Two confirmations means after this block, two more blocks are added. Always we wait for 6 confirmation to confirm a transaction really happened. That is because every miner in the network participates in mining. Every miner competes to calculate, to find this nonce to build a block, because they get huge reward for mining. And of all 9,000 nodes, let's say two nodes succeeded in finding this. Now 2 nodes broadcast the block to the other nodes. And it depends on which node can broadcast the block to majority of the nodes. That block will be included in the blockchain. The other block will be rejected by the miners. And a block which is there on the longest chain is valid. So the other miner who has competed have lost all the computation power which was spent on building this block, which is huge at this point with the proof of work consensus algorithm. It takes a lot of time to calculate to find the nonce. All the miners start from nonce 1, 2, 3, 4. They substitute that number and then find the hash of this block and see if that is less than some target value. So they spend a lot of electricity and the resources to find this nonce. So right now that's why the huge amount of electricity is used for Bitcoin mining. And it is secure. That's because if somebody wants to change something, they have that has to be propagated across all 9,000 nodes. And if more people are fraud, then it will be accepted. Like 50% of the network has to agree on something to change something. Bitcoin uses a language called script. And script is not a Turing complete language. It supports addition, subtraction, very limited operations, because this is only for currency transfer, nothing more than that. We don't divide, multiply here. It just add and subtract the funds from one account, one address to another address. Every transaction is locked by the receiver public address, and they can unlock using their private key. Unless somebody knows your private key, your funds are always safe on the chain. Every blockchain holds these three principles: consensus, cryptography, and distributed computing. All the blockchains have the same concepts. Only difference is whether it is public or permissioned private blockchains. Between Bitcoin, we can either mine or transact. We cannot do anything else on the Bitcoin network. Whereas the next version of the blockchain is Ethereum.
So, one question is, so blockchain, right? So apart
Yeah.
from its, financial transactions, so where else blockchain can be used? It's more like to prevent some request which is coming from A to B. You can use blockchain and make sure that in between the request is not getting changed. So, what is the practical use apart from financial trade, like building APIs?
Yeah.
Apart from
Blockchain has multiple use cases. Any use case where multiple participants are involved and there is a lack of trust, we can use blockchain there. Blockchain, we can store any information, not only the financial transactions, any transaction. Basically, it is a shared ledger, right? Ledger means it's a record of who owns what, that's all. So you can record the proof of something happened over blockchain. For example, I'll give you this. In the hospital industry, if multiple hospitals are there on the network, hospital A, hospital B, and hospital C, let's say, and then we have a health ministry in the same network. The health ministry asks the hospitals to record the diagnosis reports on the blockchain. In blockchain, we do not have to store the report entirely, but we can store the hash of the report on the blockchain, because hash doesn't change unless you change some letter or a space in the report. When now, since health ministry is there on the chain, health ministry has the visibility of all the diagnosis reports. Anybody complains, any hospital does a wrong diagnosis and a patient files a complaint. Now health ministry has the proof that the diagnosis is wrong or right? That's one use case. There are plenty of such use cases where blockchain is useful.
Okay.
For example, in supply chain, blockchain is used there to track the goods. So all the participants in that supply chain will be part of the network. Everybody has the visibility of the current status of the goods.
I think Walmart uses blockchain
Yes.
for supply chain, I think.
Yeah. Many companies are now started adopting blockchain. With Bitcoin, like I said earlier, there is not much we can do with the Bitcoin. Either we use the currency or mint. The next version of the Bitcoin blockchain is Ethereum. In Ethereum, there's a concept called smart contracts. We can write business logic as a contract and save the contract on the blockchain. Using this contract, we can record some transactions like rental agreements. I can make a rental agreement as a smart contract and store in the blockchain. Whenever somebody pays, uh, let us say I'm accepting a rent in ethers. The person rentee will pay the money to the contract, and then from the contract, if I want to split that money among multiple people, let's say two three friends bought the apartment together, now they want to share the rent. So automatically in the contract we can write, once the amount is received, we can immediately split the money by 3, or depending upon the percentage the friends holds the apartment, we can transfer the money immediately. So this is all automated. Once the contract is there on the blockchain, nobody can change the contract now. It is safe and automated. The contract uh, looks like this. Show you. So this is the voting contract. The language used for the smart contracts is Solidity. It looks similar to JavaScript. The variables we see here are called as state variables. These are saved in the blockchain forever. So in this way, we can write smart contracts on Ethereum. That's why Ethereum is more popular, and it is used for plenty of use cases where the funds have to be distributed across multiple parties, like NGOs are using to distribute the amount to the students for scholarships. Many organizations are using Ethereum for this purpose. And one more thing, when we use Ethereum blockchain for the smart contracts, we need to pay to the platform for using the computational power and then the storage. Because the transactions are stored in the network among all the nodes forever. The fee that we pay to the platform is called the gas, and we pay it in GUIs. GUI is a denomination of Ether. Ether has multiple denominations, like we have multiple denominations in our currency. Ether has multiple denominations, GUI, WEI, they have 6, 7 denominations.
So one question, when you keep on telling that it's stored on network node, what do you mean exactly by that? Network node means, can you just explain me?
Yeah. When I say node, any computer that is executing Bitcoin software or Ethereum software.
Okay.
Yeah. In Ethereum, there are two kinds of addresses. One is account address, like external account address, bank account, we can say, resemble analogy for analogy. And the second address is contract address. When we deploy a contract on the Ethereum network, an address is stored where that contract is saved. With that address, we can do multiple things, like we can invoke the functions written in the contract, or we can pay ethers to the contract. Contract can also store some ether, and then we can transfer the ether later. We can run these bidding contracts. All the bid amount will be stored in the contract, and then finally at the end of the bid, the winner will be declared and the rest of the amount will be transferred back to the other people who lost the bid. That was one use case for Ether. These are the blocks. If we see, the block time in Ethereum is 15 seconds. This is the block height, timestamp, transactions. Here we have 232 transactions, which means these are Ether transactions. Somebody is transferring Ether to somebody. And then 79 contract internal transactions. These are the calls to the smart contracts deployed on the Ethereum network. And mined by this address, block reward is 2 ethers plus this is the transaction fee. Uncles, I will explain it in the next class. Basically, uncle is like I explained, when multiple participants, miners, compete to build a block. In Bitcoin, the network accepts one block and the other block will be rejected. Whereas in Ethereum, the other block, if both the blocks have different transactions and both the blocks are mined at the same time and are valid, then one becomes an uncle to the current block. The computation power will not be wasted in Ethereum. And then the miners who has mined the uncle reward will get slightly lesser block reward. And this is the gas used. Gas is nothing but the unit computation power used to perform one operation. And every network, Ethereum network has the gas limit so that a miner can spend only this amount of gas to build a block. This is to avoid any infinite loops that people have written in the smart contracts. Otherwise, it will eat up the network. Also, it will control the number of transactions that can be included in a block. Gas fees is also used to control the invalid transactions or the dummy transactions that people want to play with. When we are for the developers, there are test networks for either Rinkebai, Rompston, Goerli. There are multiple test networks where we can deploy our smart contracts and learn and test. For that, we will get uh, ethers for free from the respective faucets. Each test network has a faucet. We can request for some ether. The test network will give us some ethers. We can use that ethers to deploy the smart contracts and test. We can use MetaMask wallet. I was using MetaMask wallet to create an address, and then using that account address, we can request for dummy ethers. I can give you a demo of smart contract deployment in my next session. Any questions on the Ethereum network?
So again, to the same question which I asked previously. So apart from this, right? Apart from like financial transaction, whereas Ethereum is used in other industries, like as I told, right? Like
it can be used in supply chain. See, anywhere shared ledger is useful, and then it is public. The data can be seen by anyone in the world, then we can use Ethereum network there. If the data has to be visible only to a group of participants, then we can use permissioned networks like Hyperledger Besu. Besu is a client of Ethereum, which has this ability to control the participants that can be involved in the network. In that case, only the participants on the network can see the data. Anytime blockchain is useful, if the data can be shared among multiple participants and then participants do not have trust, it will reduce the amount of handshakes that happens in the business. Right? Everybody has the visibility of the same data. Everybody has the visibility of the same data.
Yes, one
Yeah.
question.
Yeah, sure.
Yeah, if we have to create a small blockchain application, how to do it? Yes, I understood the concept that okay, how it is working that, but if we have to
Right.
create it from the scratch, that how can we go ahead and how can we create this?
You can create pick one technology and can create the blockchain from scratch. Like JavaScript, you can create. It's a data structure, right? Array of transactions and then array of blocks. Each block has the hash of previous block, and use SHA-56, SHA-256 libraries to build the hash, and then define a difficulty level 1 or 2.
Okay.
Yeah, and then you can build it as a node.
Okay, so we have to use something like the Etherscan also for using the blockchain, or just we can create it.
No,
What?
Etherscan is just an explorer which is reading the transactions and the information from the Ethereum node and displays it in a user readable format for us here. We can also create a node that we can join mainnet. See, the main Ethereum network is called as Ethereum mainnet. I forgot to tell you that. We can create a node and join Ethereum mainnet. It will take some days to sync the whole blockchain database, and then you need to have around 2 GB to 1 terabyte, or should see how what is the current size of the chain. If you have enough storage, you can create a node and then use the Web3 libraries to read transactions or block information from that and then build Explorer. Anybody can do that. This is just an Explorer which is showing information from the blockchain, that's all. When you build a blockchain, your own private blockchain, you need to write Explorers for yourself. You need to spin up the node and then write Explorer to display transactions from the private or the new blockchain which you have built. When we create our own blockchain, we need to write the consensus algorithms, and whether it's private or public, need to add all those elements to it. Ethereum uses Keka 256 cryptographic function. And then we have a concept called public key, private key pair in blockchain. Public key is like a username, private key is the password. First, private key is generated, and then using a hashing function, public key is generated, and on top of that public key, another hash function is applied, and then this address is generated. This address is public, it can be used everywhere. Private key is the secret using which we can unlock the funds and use the funds. This is about Ether, which is again another public blockchain. Now, like you people asked whether this can be utilized in multiple use cases, right? Not all use cases involves public data. Many organizations have private data that they can share among a few business partners. For enterprise applications, we have Hyperledger Fabric. It's a permissioned blockchain. In that blockchain, participants will be added using the authorization, and then the data can also be controlled in channels that we will discuss in detail. That's a permissioned blockchain. So it depends upon the use case. The block we can decide which blockchain we can implement. It's not that every use case needs to be on blockchain. Any other questions on the concepts till we discussed?
So I have a question here.
Yeah.
How to decide what blockchain technology to use?
Okay. Yeah. If the use case has shared data and then limited participants, we can use Hyperledger Fabric or Hyperledger Besu. Hyperledger Besu is a Ethereum client. Hyperledger Fabric is a different blockchain. And then whether we allow the participants or the network to pay the gas or not, right? If we want to go to the public blockchain, then we need to pay gas to the platform, which is very high. But there are level 2 solutions on Ethereum, which is Polygon layer 2, which will reduce the fee. There we pay in Matic, that is the native currency of Polygon network, that will reduce the amount of gas fee. So it depends upon the use case, whether it is public. If it is public, we have some options. If it is private, there are some options. So people can think whether to go with Ethereum or Hyperledger Fabric. Again, there are some considerations that we can take care of, the complexity of the technology and all. For Ether, people should have the solidity skill. And also the upgrade capability. Smart contract once deployed on Ethereum, we cannot change it because it is tied to a particular address. If we deploy it again, it will be stored in a new address. And then the user interfaces which are pointing to the old contract now have to point to the new contract, and also the data is stored in the old contract. We need to migrate that to the new contract, which is not easy and it's a complex way. Whereas in Hyperledger Fabric, it is a permissioned chain, and then there is a flexibility for upgrade. We can upgrade the contracts there in Hyperledger Fabric.
Sure. And can you also explain about what are smart contracts?
Yeah, smart contract is a business logic. I'll show you in a very small. This is the remix IDE which I'm showing here. This is built by Ethereum group to write smart contracts and deploy on the network. So this is how a smart contract looks. It looks like a Java class where there are some class variables and then functions to change the state of the variables. What is stored on the blockchain is the bytecode of the smart contract. This smart contract has to be compiled. Once we compile, it will generate bytecode. This is the bytecode. So this is the machine language. This bytecode, we can deploy it. This is the deploy. The remix gives us the test accounts here. This is the local environment where we can deploy. Now I'm in the deploy window, selected the local JavaScript, local blockchain. In the contract I selected, I'm deploying it. When I deployed, if you observe, my account had earlier 100 ethers, now it is reduced. For the deployment transactions, it will take some gas.
So these are all contracts, right? You're writing.
Yes, these are contracts. See, the store and the retrieve functions. If I store some number, now the transaction is committed. Here, if we observe here, gas, transaction cost, the total gas execution cost. This was the total gas used for this transaction. And then the amount number stored is 45. And when I say retrieve, I see the value. Retrieve is of type view, so it won't cost us gas. Should not cost us gas. There is no gas here. View function means it's a read-only function. It does not write or change the state of the variable blockchain state. It won't change blockchain state, so it will get the value from the node which is attached to it. Just reads the value. For that, there is no gas.
Yeah. So one question is, so all
Yeah.
these information, right? You're telling that it gets stored on the network, right? So is it written as a file, or it has its own storage system, because somewhere it has to get persisted, right?
Yes, it has its own storage system.
So is it like database, or it has its own structure?
It is database level DB.
Okay.
Yeah. So this is how a smart contract looks. We can write any business use case here, right? Just some variables and then logic to change the state of those variables. These variables have storage that is stored in the blockchain.
Okay, looks good.
Yeah. We can connect to any network from here. It is injected provider MetaMask. I do not have MetaMask right now. When we have MetaMask, in MetaMask, we can select the network that we want to connect to. Once we have connected to that network in the MetaMask, we can use this injected provider. And when we say deploy, it will use the account that is selected in MetaMask and deploys into that network. For the actual development, we can use Truffle or hard hat frameworks, which helps us to deploy and test the smart contracts. Yeah, that's all for today. Thank you. I hope you enjoyed the session.
Yeah, it was good
Really,
session.
yeah, it was really good, and yeah, at least it gave me some understanding of Bitcoin.
Yeah, it also, I was not knowing the first time I'm seeing that.
Yeah. I think it's very important to understand the concept, blockchain itself.
Yeah,
When we are moving to cryptocurrency world, right?
yeah,
Need to understand. We were not there when fiat currency is created, and we don't know how the value it got, right? Currency is nothing but a social consensus. That's all. Like how Bitcoin got the value, it is based upon a transaction, and then from then on, people are accepting Bitcoins. When you have the consensus, then the value increases or decreases.
Great, Saujanya, very informative. And also, you showed the demonstration with live examples as well. So, this was really very useful and easy to understand. And
Yeah.
yes, no, more details you can cover in upcoming sessions because, yes, a lot of concepts to understand, but you gave a very good overview in this session.
Yeah, right. That's the agenda of this session, to get an overview so people can dig through some articles, and they would understand now if they hear some news about
Yes,
blockchain.
yes,
Yeah,
great.
sure.
Great. So,
Thank
yes, no, we are almost done with the time. So, if nothing else, we can close this session.
Sure. You were all very great audience.
Sure, yeah. I felt, yeah, it was very nice, interactive session, and no, thanks everyone for asking questions and making this session more useful. Okay, see you then
Yeah,
next
thank you.
next
Bye.
week. Yes.
Sure.
Yeah.
Bye bye.
Thanks a lot. Thank you, guys.
Okay,
Thank you.
bye.
Thank
Have a
you.
nice
Thank you.
Sunday.
Bye-bye.